Hello lovely people, what's poppin' y'all? In today's video, we are solving minimum removals to balance array Leetcode problem. This is a medium problem, so now I'll walk you through the integration, optimization and final effective solution. We are going to use sorting and two-pointer approach. So what are they asking in the question? We are given an integer array nums and an integer k. You may remove any number of elements, but the array cannot become empty. So an array is called balanced if the maximum element is smaller than or equal to minimum element times k. So our goal is to return the minimum number of removals needed to make the array balanced. So what is the key observation here? Instead of focusing on which element to remove, we focus on finding the largest subarray that is already balanced. So once we know its length, we can find it like removals is equal to total length minus longest balanced subarray. So this shifts the problem from brute force removals to window size, sliding windows. So why does sorting help here? After sorting the array, the leftmost element becomes the smallest and the rightmost element is the largest. This makes us checking the condition, the left element times k if it is larger than or equal to the right element. Here we maintain two pointers, or basically the sliding window idea. We maintain a left pointer and move the right pointer across the array. If this condition is violated, the left element times k is smaller than the right element, we move left forward to shrink the size of the window. At each step, we update the maximum valid window length. Now let us look at an example for better understanding. So let us take 1, 2 and 5 and k is equal to 2. So when we sort it, it becomes 1, 2 and 5. The first window is 1 and 2, the left pointer being 1 and the right pointer being 2. Here this window is valid because the element that is being pointed by the left pointer here is 1 times k. Here k is 2, which is equal to 2, is strictly smaller than or equal to the element that is being pointed by the right pointer, which is 2 here. So this window subarray is valid. Here we update the length of the subarray and then we expand the window length, which moves the right pointer to the next element, which will be 1, 2 and 5. Here this window becomes invalid. Why? Because 1 into 2 is 2 and 2 is smaller than 5, which invalidates the given condition for a balanced subarray. So if we shrink the window by moving the left pointer to one step forward, it becomes 2 and 5. This also becomes invalid because 2 into 2 is 4 and 4 is lesser than 5. If we again shrink by moving the left pointer one more step forward, it just becomes 5 and 5 is a valid balanced array. So the longest valid length will be 2. So removals will be 3 minus 2, which will be 1. The time and space complexity for this will be O of n log n for sorting, and space is O of 1 extra depending on the language of the code. Now let us take a look at the code. So first we are initializing a variable n to store the length of the array, and then we are sorting the array. Now we are initializing the left pointer. We keep it as 0 and variable to store the max length of the balanced array. And then we are initializing a for loop for right in range of n. So we have to shrink the window until it's balanced. So again we are initializing a while loop so that left does not overtake right. So we keep left smaller than right and the value of left into given target is strictly smaller than value of right pointer. So in this we keep increasing the left pointer values, and then we update the max length. We have to find the max length by finding the maximum between the max length or the right minus left plus 1. Plus 1 is because of the index values, because it is 0 indexed, and then we return n minus max length, where n is the full length of the array. This should run. Yeah, this is running. As you can see, it is the most optimal solution. So that's all for today. Hope you guys enjoyed today's video. See you in the next one. Bye bye.